branching and decision making. The basic learning outcomes or the objectives would be to understand four very important conditional statements. The first one being if. We're going to see different forms of if statements, switch case, conditional operator, or we also call it as ternary operator, and finally the Goto statement. So to begin with, C language processes decision-making capabilities by supporting these four statements, and these statements are popularly known as decision-making statements. The if is the powerful decision-making statement and is used to control the flow of execution of statements. It is a two-way decision statement and used along with expressions. You can see on the screen the general format of if. I have a if keyword followed by the test expression enclosed within braces. The flowchart for if is given on the screen. The condition is checked. This is a two-way conditional branching. If the condition evaluates to true, then a set of statements are executed. If it evaluates to false, then the other set of statements are executed. Now here we can see a simple if statement. The general format of it goes something like this. If the keyword, condition enclosed within braces, and then you have a simple statement or a compound statement. If it is compound statement, then we will be enclosing this compound statement within flower brackets. Sometimes we also call it as a block. The simple if statements flowchart is given in the slide, the presentation. You can see here the condition is checked. If it is true, the statements within the if conditional statement gets executed. Else, if the condition evaluates to false, the control comes out. So it executes the rest of the statements in the program. This is a small example program where we are trying to find the absolute value. So I've declared an integer variable num equal to 0. I've initialized it. Initialization is actually not required, but then I accept num from the user. Num is compared. I'm trying to check whether num is lesser than 0. Now, if it is lesser than 0, obviously the number will be a negative number. So I'm multiplying -1 with that number. So minus negative value into a negative value will be a positive value. So obviously I'm trying to display that num value, which is positive num. If it is positive,
So,
yeah.
Sir, why there is -1 here? Num star equal to -1.
Yeah, now this you can interpret as num equal to num into -1. So any value that is multiplied with -1. Say if my number is positive, then this condition will evaluate to false. Num is obviously greater than 0 if it is positive, right?
Yeah,
So
yeah.
the control does not get into if condition. It comes out, it will just display the positive number. If the number is negative, obviously it will be lesser than 0,
Yeah.
right? So number is negative. So num into -1. So minus into minus, you get plus. The number gets converted into positive number. It will get displayed here. Is that fine?
Okay. Yes, sir.
Okay. This is the second type of if statement where you have both if as well as else. The flowchart represents the second type of if else statement. A condition is checked. If the condition evaluates to true, then the statements under if block gets executed. If it evaluates to false, then the statement under else gets executed. So this is the standard syntax of if else statement. You can see here, if I have a condition here, I have given two braces, open braces and closed braces. It's not actually required. One is sufficient. So condition, if this condition evaluates to true, then the statements within the if gets executed. If condition evaluates to false, then the statement within the else clause will get executed, and then the control moves on to the next statement after if else statement. This is a simple example, a code snapshot where I've declared and initialized AB, declared C, A is equal to 15, B equal to 10. If A is lesser than equal to B, that is, in our case here, A is 15, B is 10. So obviously 15 is not lesser than equal to 10. Condition fails. If the condition fails, obviously the statements in the else clause gets executed. So A is incremented by 1, so it becomes a 16. B is incremented by 1, it becomes 11. So A is 16, B is 11. It prints that. Okay, this is another example where I'll be accepting two values, A and B. If B is equal to 0, then I say invalid value. If B is not equal to 0, then these two statements will get executed, which is part of my else clause. So these two statements will get executed if B is not equal to 0. Here you can see that A is 12, B is 5. So B is not equal to 0, so it will execute the statement. So C is equal to 12 by 5, which is 2.4. It gets displayed. So here I'm deliberately giving 0, assigning 0 to B. So obviously my if conditional statement will evaluate to true, and it will print the statement invalid value of B. So C, what will be the value of C in that case? The value of C will be garbage. Okay, now this is another example where I'm trying to find out whether the given number is odd or even. How do I do that? Printf statement, scanf, I'm accepting n, n mod 2. So anything divided by 2. Now here I'm trying to find out the remainder. If the number is odd, then the remainder will be 1. If the number is even, then the remainder will be 0. Isn't it? So if n is an even number, then I'll print n is equal to even. If it is odd, then I'll print n is equal to odd. Now see the condition here. This is very important to note. I'm trying to find out the modulus of a number, trying to find out the remainder of a number when I divide it by 2. Any doubts up till now?
Excuse me, sir.
The percentage indicates it's the division, whatever we are doing, sir.
Yeah, it'll give you the remainder. It will give you the remainder. It's a mod operator. It will give you the remainder. Say for example, you have n, you are giving 14 to n, assigning 14 to n. In that case, 14 mod 2. What will be the remainder of 14 mod 2? It will be 0, right?
0.
Yeah, and 14 is an even number. So similarly, if say I assign 17 to n, 17 mod 2 will be 1. So obviously this condition will evaluate to false. This condition evaluates to false. So the statement under else will get executed. So it will print number is odd.
Okay, sir.
Yeah. The third type of statement. See, when a series of decisions are involved, if else statement nested form is used, which means that, say, instead of just checking for one condition, you have multiple conditions to check, then you can use if within another if. So this levels can go on increasing, and here you can see in the right side of my slide, I have if expression 1, that is the outermost if, and within that I have another if expression 2. So this levels can go on increasing. Okay, so let me give you the flowchart for if nested if statement. So this if else condition is enclosed within this if condition. Okay, I'll show you another example program, you'll understand better. So this is a simple code snapshot which gives us an idea of how nested if else works. So you can see here that I have a if condition statement. So this is the first level of if else statement, and within this if I have another if else statement. So I can have an if else, I can just have a if statement, or I can just have a block of statement without if. It works fine. But here you can see I have two levels of if else statement. So this is called as nested if else statement. Let us see an example to understand this better. So here I'm trying to find out the smallest among three numbers. So when I say three numbers, I'll accept three numbers from the user, A, B, and C. So I'm trying to check here whether A is lesser than B. If it is true, then I will check A lesser than C. Obviously, when this condition evaluates to true, the control enters inside this if condition. And this is also true. It means that A is lesser than B, A is also lesser than C. In that case, I assign A to S so that I will display S as a smallest number. Now, if this condition evaluates to true, but then if this condition evaluates to false, which means that A is lesser than B, no doubt, right? But if this condition fails, it obviously means that A is lesser than B, but C is lesser than A. So in that case, C becomes smaller. So if this condition fails in the first place, A is lesser than B if it fails, which means you need to just compare B and C. So that is done here. So here you are comparing B less than C. If that is the case, B is lesser, else C is lesser, or the smaller number. So you come out and display yes. So this program gives us an idea of how to find out the smallest of three numbers. It can be further enhanced to 4, 5, or even n numbers. N numbers, you cannot use such a logic. You have to use a looping construct to extract each individual number and then compare it with the smallest number. Okay. Sometimes there are another ways of putting if together with multipath decisions are when multipath decisions are involved. So you just don't have one or two conditions to check, you have multiple conditions to check. In that case, the multipath decision is a chain of ifs in which the statement associated with each else is an if. It takes this form that is displayed here, it takes this form. Whereas you go on checking for multiple condition, and whichever condition evaluates to true, the corresponding statements will get executed. So this is the flow chart. The control enters here, checks for condition 1. If it is yes, then it will execute the statement under that condition. It comes out. False, it moves on to the next condition to check. If else, it executes the statement under that if condition and comes out, or else it will move on to the next condition, goes on checking this. So it depends on how many conditions that you have given in an if else ladder. Let's see an example program. So I've just taken 3 levels here. Here we are trying to check whether the number is 0, positive, or integer. N is the integer variable that I've considered here. I'll accept the value n from the user and try to check whether n is equal to 0. If it is equal to 0, then I say the number is 0. Else, if the number is greater than 0, which means that it's a positive number, I'll just print the number is positive. Else, I say the number is negative. So if else, so this entire set of statements are part of this this else, and under this else I have if else. So this can actually continue, but this problem demands only 3 levels, so I've considered only 3 levels. Okay. Now we have seen that when one of the many alternatives is to be selected, we can use if else or if else ladder to control the selection. But if the number of conditions increases, it becomes complicated for us to track or to represent the conditions. So to overcome this, C provides us with a construct called a switch, which is used for multi-way selection. This is the standard format. Here we can see switch is a keyword. You can switch accompanies with an expression. Within switch, you have different cases. Depending on what this expression, what value it represents, the switch, the corresponding cases will get executed. So say for example here, the expression evaluates to value 1, then the block within this value 1 gets executed. If it evaluates to value 2, then the block within case value 2 will get executed. If none of the values are generated from the expression, then the default statements under the default class will get executed. Now we should observe here that every case, end of the case statement, we have a break keyword. Default is optional in switch case, and break is also optional at the end. So this is the flow chart. So you have an expression that gets evaluated based on what value you get. Say for example, if you get 1 statements under case 1, it gets executed. If it evaluates to 2, then statement under case 2 will get executed, and so on. If none of it is generated, then obviously default statements will get executed. Now this is a simple example of multi-way selection of the switch case statement. X is equal to 1, declared it as integer, y is equal to 12, z equal to 14. Switch X, Obviously, x value is 1, so it will not execute these statements. Rather, directly it will jump to case 1. So x value becomes 4. Y is incremented by 1. The value of y is previously 12 that I was assigned. Now it becomes 13. So y is 4. Sorry, x is 4. Y is 13. Will pass on the control out of this switch case statement, so directly the control comes down to printf statement, so it will print x. What is the value of x? It is 4. Y has become 13 now. Z value is 4.
So why can't the case 0 execute?
Yeah, so say for example, there is a slight change. See why, I'll get back to your question. Yeah, why? Because
Okay.
x value is 1 here. X value is 1. See, here we have switch x. Now the cases within the switch depends on what value that you pass to x. Here, the x, say for example, if we would have had 0, we would have initialized 0 to x, then case 0 will get executed. Forget about the values that we are going to change to x within the case, but we need to focus on this value that we have given with respect to the case. So since x is equal to 1, it will execute this part of the code, case equal to 1.
Okay, so that
If
switch X means the case condition thing.
yes, this value x gets substituted here. Okay, so since x is equal to 1 here, so it will execute case 1 where x value is assigned 4, y value is incremented by 1, which is 13. It should have displayed 13. C is equal to 1. Now it became 13. So x is 4, y is 13, z is 4. Any doubts in this?
No, sir.
Yeah. So you can just try out these code. You can just make 0 here, x is equal to 0, and note down the output. So it should print 2, 3, and 4. Okay, 2, 3, and 4. If you change this to 0, if you change x value from 1 to 0, it should print 2, 3, and 4. Okay, this is another example. We have a if-else ladder statement. Now, we can try converting this into switch case statement. Very simple. Here we had if ch equal to e. Now why single quotes? Because e represents a character. Now you should observe that switch case, switch in the expression form accepts integral values, which means that it will accept integer or character. No other data type will be accepted here. So e, in that case, count 1, I'm incrementing it by 1 and then give a break. Similarly here, case A, count 2, I'm incrementing it by 1, give a break. Case I, count 3, I'm incrementing, give a break. Default, here I just have an else, so default print error. Don't you think this is much easier code than if else ladder? This is the second example. Very similar to the previous one. This is vice versa. Switch, we are converting it into if else ladder. So please go through this. If you have any doubts, you can get back to me. Now this is a good program where we are trying to accept integer values from 1 to 7, any one value from 1 to 7. Depending on what integer value that you are going to give, we are going to display the corresponding day of that week. Okay, so if it is 1, then I'll display Sunday. If you give 2 as an input, I'll display Monday. If it is 3, then it is Tuesday, and so on. So 7, Sunday, default. If you give any other value apart from 1 to 7, then it says invalid number. So you can try out all these programs. This program is a simple calculator program. I've used a switch case. This is part of your lab exercise, so you can just focus on this. I've declared 3 variables, A, B, C of type float, character to represent the operand. See, in an expression you have operators and operands. Let's take this expression, C equal to A plus B. A plus B, C A, B are called operands, plus and equal to are operators. Now we are interested in what sort of operator that we are going to use. Based on that, I need to perform the computation. So what I do is I declare 3 floating point variables, 1 character variable to store the operator. Then I'll accept the operands and operators, A, B, and the operator. So A, B are the operands of type float, and C would be the operator. So I would say 3 plus 4. Want to perform an addition operation, or say 6 minus 2 to perform subtraction operation. So I'm using a switch case statement, switch operator. Operator. So it depends on what sort of operator that I am giving. Say if I give 2 plus 5, so plus is red here, and the case with plus gets executed. So A is 2 plus 3 is 5. Similarly, if I give minus, these set of statements are executed. Star, these set of statements are executed. Slash, divide. I cannot directly divide a number by 0. So I'm checking that condition. If it is B is equal to 0, then I say I cannot divide by 0 and I'll exit, come out of the program. Or else I'll divide and print the quotient. Default invalid operator. Any operator apart from plus, minus, divide, and star I give, it says invalid operator. So these are some of the rules for switch case. Expression that follows the key word switch must be an integral type. That is what I said, integer or character. Constant values can be only integer or character. No two case labels can have the same values. So we had case 1, case 2, case 3. So you cannot have 2 cases. It's a clash. Your compiler will give you an error. It cannot be used for a range of values. So say for example, if I want to find out whether C lies between 2 to 10, that range I cannot specify. Similarly, values cannot be compared with the logical or relational operators. It can just be only the equals operator can be used. Default case is optional. So if you don't have any statements for default, you can just leave it. Okay, now these are some of the example programs. I'll quickly run through this. So x is equal to 0, y equal to 1, z equal to 1. So obviously somebody did ask me why not case 0 to be executed. Now it will execute. So x value will be 2, y value will be 3, z value will be 1. So now these are the initial values. Now it is changed. After the execution, it will change. X is equal to 2, y is equal to 3, z remains 1. Okay. This is somewhat tricky. Can anybody tell me what is What is the unique thing that you find in this program snapshot?
There's no break statement in
Yeah, there is no break. There is no break after case 0, and there is no break after default. The default, it's not actually required. But what happens if you don't give break at the end of case 0? Let's see this. So x value is 0.
It'll execute case 1.
Yeah, obviously it'll execute case 1, case 0. It'll continue with case 1 also. Let's see that. X equal to 0, y is equal to 1, z equal to 1. So now x changes to 2, y changes to 3, right? And then the control moves on to the next set of statements also, because you don't have a break. So x should become 4, right? So this is the output: 4, 3, 1, x, y, z. Similarly, here we have x is equal to 1. These two statements are executed. Then again, it will continue executing these statements here in case 2. So you can see that the values are 3, minus 1, and 6. Okay, we'll rewrite this statements using switch case. Here, can anybody tell me that we have two conditions here? We are clubbing these two conditions using OR, a logical OR operator. How do we represent this using switch case? This is one way of doing. This is one way of doing. The other way of doing is you repeat the same two statements, giving case E, separating case uppercase E and lowercase e. But then you can club these statements using two different cases. Give a colon here, case E, case lowercase e, and two statements that needs to be executed, right? So clubbing of options is also available in switch case. Yeah, the next next statement. This operator is useful for making two-way decisions, and is a combination of question mark and a colon, and it takes 3 operands. Conditional expression, question mark, expression 1 and expression 2 separated by a colon. This is also called as a ternary operator. Why ternary? Because it has 3 operands. So this is a simple example where you can use ternary operator instead of if conditional statement. So you can specify it as x less than 0, question mark, flag equal to 0, colon, flag equal to 1. So it behaves very similar to this conditional statement where we have used if and else. In fact, we have dealt with this ternary operator previously in my sessions. So you can try out this program to find out largest of two numbers using conditional operators. Okay, this is an example where I've found out whether x is lesser than 0 or greater than or equal to greater than 0. Okay, the next C supports the Goto statements to branch unconditionally from one point to another point in a program. We have two different types of Goto statements. One is the forward jump statement, the other one is the backward jump statement. Forward jump statement where you have a Goto keyword and followed by the label. Label is a standard identifier. You can apply these rules of an identifier to create a label, and then automatically it will skip the statements next to Goto and directly shift the control to the label where to the statement where the label is placed. Similarly, the backward jump is the opposite side, the reverse side. Let's see a simple example program. I have a main function here, declared two variables, x, y as double. Scanf, I'm accepting x from the user. So I'm trying to check whether x is lesser than 0. If it's a negative number, then I say go to read. Again, go back and read the value again. So this happens until the user gives either 0 as an input to x or positive number for x. If it is positive or 0, say he gives a positive number, then automatically this condition fails. Control moves on to the next line. It will find out the square root of x, pushes that square root of x into y, and it will print x and y. So you say square root of x is equal to y. Again, go back to the statement, read statement. So this follows, this continues. It becomes an infinite loop. So these are the assignment questions that I want you all to try. Since I'll be sharing this video, you can just note down these assignment questions and try out on your comparison.